Today we're going to be walking through a test-driven development workflow in Godot. Specifically, we're going to use a library called GUT. It's an acronym, GUT, stands for Godot Unit Test. GUT is a great library and widely accepted as the standard in the Godot community for testing. It's going to enable us to write tests for our game that verify our code works as expected without needing us to fire up the game and manually play through every situation. So this is really handy for projects that get really big and can be tedious to test every single situation or every single different level. But more importantly, it protects us from regressions, where maybe something is working okay right now, but then we come in and add something elsewhere in the project that accidentally breaks the thing that was working before. These tests are going to help us identify those quickly so that we don't end up breaking the game. So whether you have TDD experience already, maybe in a different language and just haven't tried it in Godot yet, or you're completely new to testing, this video is for you. So before we get started here, quick reminder that I upload game dev tutorials and content to this YouTube channel, so if you're into that kind of thing, feel free to subscribe for more. So if you've never worked with TDD or unit testing, here's my quick summary of the concept. When we're building our game, we're going to be writing the code that makes our game work, of course, but also on the side, we're going to be writing test scripts. And those test scripts are going to look at our game code and run that code in isolation and verify that that code is doing what we expect it to be doing. Okay, the first thing we're going to do is install GUT. And so here I have a new blank Godot project. I'm going to pop open the asset lib up here. And then in the search box, I'm going to type GUT, search for GUT. It's the first hit here. It's this one by BitWest. Thank you, BitWest. Link to GUT will be in the description below. We'll go ahead and click it, and then we'll choose download. Now this downloaded a bunch of files into our project. We can go ahead and hit install to use the files, and then we'll go ahead and make sure that everything is checked here and hit install again. And now we get our success, yay. So I'll hit OK to close out of that. The next thing we need to do is actually activate GUT in our project. And so we're going to go up to Project, Project Settings, Plugins, select GUT. In this dropdown over here, we're going to change inactive to active, and then close out. Now we should be all good to use GUT. Now let's go ahead and pop back to our 2D editor. And first thing we're going to do is actually create our test runner. And so I'm going to go ahead and, this is our main scene, but I'll go ahead and make a new one and say other node, and in here we can search for GUT. This is the kind of type of node that we installed into the project. And so I'll go ahead and create that. And I'm gonna hit save now. I'm gonna call this TestRunner. The name of it doesn't really matter, it just works for me. If I zoom in a little bit here. Now here's a preview of what GUT gave us. This little window is gonna be the area that our tests get run in. If you inspect the GUT element over here, you can see that the inspector has like all kinds of different options. All this stuff is documented really well in the documentation, which again will be linked below. Now I'm going to go ahead and kind of grab the corner here and just make the whole window bigger to make it better for the video. And if I hit Command R or Control R, it's going to run just this test runner scene by itself. And here's kind of what it looks like. You can resize it in here too, which is very cool. And as you can see here, it says no scripts available. That's because under the hood, GUT is going to look through some of these directories that we can configure. Here you go, like directory 1, directory 2, and look for test scripts to find and run. But we haven't created any yet, so we're going to do that now. So down here in the file system, I'm going to expand this to make it a little easier to see. I'm going to create a new directory in the project, and I'm going to call it test. And then inside test, I'm going to go ahead and create another one called unit. This is kind of just the convention that the documentation recommends and uses. You can use whatever structure you want. There are a few naming conventions that will be important that we'll cover soon, but to keep it simple, I'm just going to follow what the documentation says. And now in this new unit file, I'm going to go ahead and create a new script and call it test_character.gd. So I'll hit create, and then pop it open in the editor over here. And so now we need to configure the test runner to actually run the tests in this directory. And so what I'm going to do is grab that node, the test runner that we created, and then in the inspector over here, come down to this section of directories. I'm going to change the first one and spindle down to test unit, and then say select current folder. Now when we run the tests, it's going to scan every file in this directory and then use those. Also, real quick, just to prevent some confusion, I'm going to go ahead and rename this gut node to match the scene name that it's in. This is just the default name because it's like a gut type, but I'm just going to go ahead and rename that TestRunner. And now when I run the scene, you're going to see that it really doesn't do anything different because it does pick up that we have a test file created, but that test script is empty. It's not really doing anything. So we're going to go ahead and start filling that in now. So the first thing we need to do is come up here and change the extends of this script. I'm just going to go ahead and paste it in, but it's important that we extend off the actual test class that Gut has given us. And so the link to that is going to be in add-ons gut test.gd. And then from here, now we can start to use some of the methods that come with Gut. So Gut's going to look for some naming conventions. So if we make our first kind of test method, I'm going to say func test underscore, I don't know, some method. We're going to go ahead and change this in a second. The fact that this begins with test is telling Gut that it's a test, right? If I take that away, then the method would no longer show up in our test runner. So we can leave that in there. And now we want to start writing tests against something, but our game is kind of completely empty right now since this is a new project. So what we're going to do is pop open and create a character class, and that character class is what we can start doing some tests against. Okay, so I'll hit this plus here, create a new scene. It can just be a 2D scene for now. I'm going to name it character and then save it also as character. It can just live in the root of our project. This isn't going to be a very visual thing, so it doesn't really matter with sprites and that kind of thing at this point. I'm going to go ahead and add a script though to our character. So we have character.gd, and now this new character class is going to be the thing that we're going to write tests against. Okay, so coming back into our test script, we need to pull in this new character class so that we can write tests against it. So I'm going to say character is going to load from the resource path. It's just at character.gd here. And then in our method here, our fake test method, I'm just going to say var character is going to be character.new to make a new instance of it. And then on this new instance, I'm going to run just some wacky method that we're going to make up on the fly here and call it some method, maybe like that, just to get the concepts flowing here. And notice that the test name is test some method. Kind of a good convention is that the name of the method that you're testing goes in the test name. That can kind of make it easy to pair together what's going on. And so character.some method, this doesn't exist yet. And what we're going to do is maybe save the output of whatever it's going to do into a result. And so I'm going to pop back into my character class here and create this method. So we called it some method. I'm just going to do something goofy right now, like return apples, just to make sure that we're getting some kind of value out of it. Okay, back to the test. So result is going to run that. It should be apples. The next thing we want, though, is to create an assertion. And so Gut comes with a bunch of assertions out of the box. The way you use them is if you just start typing assert, you'll see it auto-suggest all kinds of different ones. The documentation covers all these, of course. The ones I use most often are EQ, equal, and true. So what we're going to say is assert equal. And what this wants is for us to give it two values to compare, and then it's going to return, pass or fail if the two values are equal. And so we'll go ahead and pass in the result, which should be apples. And then just to see the test failing, I'm going to use bananas here. So we're going to assert equal that result is bananas. And then the final thing we give it is a message to show if the test fails. And so I'm going to say the result should have been bananas. And now if I hit Command R to just run the test, the tests popped up in our window here, but they didn't run by default. If you go ahead and click this play, that will actually run the tests, and then you'll see this red text here. It says, if you scroll up through it, it's going to say, uh-oh, apples expected to equal bananas, and then our message, result should have been bananas. So this is obviously a silly example, but it's telling us that the test is running against the actual code in the game, and we know that the thing we expected didn't happen, and so we have a problem. And now needing to hit that play button can be a little tedious, and so in the inspector options over here, there's this checkbox called run on load, and with that selected, when you run the test again, it's just going to automatically run. You don't need to hit that play button. Okay, and now just to see an example of a passing test, let's pop back open to character and go ahead and change this to bananas, run the test, and you'll see that everything is green and happy. We do have some orphan errors here, and we'll talk through that in a little bit. But for now, let's go ahead and start making this a little bit more real. So back in our character script here, let's go ahead and start making some kind of real game stuff. So we'll say like your HP is 100, and maybe your max HP is going to be also 100. And let's change this method. Instead of sum method, it doesn't mean anything. Let's say it's going to be take damage. And then damage amount will be like how much HP we want to reduce, that kind of thing. The term test-driven development means that instead of kind of writing the functionality code first and then backing it up with a test, you actually write the test first. So there's this pattern called red, green, refactor. And what that means is that first we want to write a failing test that doesn't have any implementation. So we see a red test fail in the test runner. Then we want to write whatever code we need to write to make the test pass. Even if the code is kind of sloppy or inefficient, it doesn't really matter. We just want to make sure that the code is doing the thing it's supposed to do. And then finally, once we have the test passing, we have the freedom to go back and refactor that code to make it nice and clean, more efficient, whatever we have to do. And we'll know that everything still works because that test will still pass. So let's go ahead and try something like that. Okay, then popping back to our test file, instead of testing some method, we're going to update this to be test take damage. We're making a new character, and then we're going to run the method, say we're going to take damage, and we're going to pass in 10. And up here, before the test runs, we can kind of just make sure that the HP is starting at 100. The idea is that when we run this method, we're going to subtract 10, and so that's going to bring us down to 90. And so what we want to do is assert equal, instead of just result, we're going to say character.hp should be equal to 90. The idea is that we start at 100, we're going to take 10 damage, and then we're left with 90. So I'll go ahead and run the test, and you can see that it's red. It says 100 expected to equal 90 because we started at 100, and there's no actual code that does that subtraction yet. One handy thing about Gut too is that you don't have to close out of the scene that's running the test. You can just kind of leave it over here. And then anytime you want to rerun the test, you just tap that play button. So let's go back to our character, and we're going to say HP minus equals amount. And so now that we have this line in, we come back to our tests and run it. You see that all tests pass. So now we know that our take damage method is actually subtracting the HP that we expect. So let's add another one. What we're going to do this time is say func test take damage not below 0. And so what if we have like 5 HP left, but we take a big hit that's more than 5? Right now that would put our HP below 0 at negative something. And so we don't want that. We want to make sure that it stops at 0. And now down here, when I'm writing the second test, I could go ahead and like copy over this part, to make a character again in character.new. This is where some utility methods come into play that come to us from Gut. They're pretty common in any testing language, testing library kind of thing, if you've done this with other languages. But they always look something like before each, and then also after each. And so basically, before any one of these tests runs, before each one, Gut is going to run this block first. And then as soon as the individual test is done running, it's going to run this after kind of cleanup. So the idea is that here you can set up this common stuff that you're doing all the time in every single test, so you don't have to retype it every time. And then here you can do some of that same cleanup every time. Furthermore, it helps make sure that every single test block is getting set up with a clean instance of whatever class you're testing. You wouldn't want operations you did to the class in this method, for example, to bleed over into this one, because then you have kind of a misleading test. So let's do some of that organization to clean up our test file here. So what we can do is start character is just null, nothing. And then here, instead of defining character each individual time in every test, we're just going to do it in the before each block. And then after each, we're going to go ahead and make sure that this character gets freed. And so you may have noticed when we run the test, we get this orphan error. That happens because a node is created inside the test, but then it's never cleaned up. And so that, in this case, that's only happening in the test, but sometimes that can be a really useful indicator that you have a memory leak in your game, which is super bad. And so here the test runner is warning us that we need to make sure we clean everything up. So this after each character free will take care of that. And now we can start on our second test. So I'll give us some more room here. And what we want to say is this time, we're going to go ahead and start. We don't have to create character because it's already created in the before each now. we're going to say character's HP is going to start at 5. And then we're going to say character dot take damage 10. We'd prefer this number never actually go below 0 because that could maybe cause some weird things with health bars or something like that. We just want to make sure it stops at 0. And so copying over our assertion, we want to make sure that character.hp equals 0, and it should be 0. So now when I run this test, this is failing, and it's failing because what it actually found is that character's HP was -5 instead of 0 because we don't have anything in our character code that's stopping the subtraction from going below 0. Okay, so moving this aside for a second, let's go into our character code, and then we'll say, to floor it, if HP is less than 0, go ahead and set HP back to 0. And now when I run the test, you see that, hey, now it passes, and we know that that bug doesn't exist because that number is never going below 0. So at this point, we've seen the test go from red, where HP was below 0, to green, where HP stops at 0. But some people might look at this code and be like, this is kind of messy, or this could be done in a more efficient or cleaner kind of way. That's where refactoring comes in. And so we know that the test is passing now. Just to see it one more time, what we can do is start changing the code and just verify that the test still passes. And so in Godot, there's actually kind of a built-in way to do this kind of flooring. What we could do is say HP is going to be equal to the maximum of either HP minus amount or 0. What maximum does, or max, takes in 2 numbers, and then it's going to take the highest one. So if it does this HP minus amount and then it comes up -5, but it's going to compare that to 0 and then take the one that's higher, which in this case is 0. And so if we try this line of code instead, we can see that it's still the same, that we've changed the code, but both tests are still passing, meaning the 100 to 90 case is working, and then the never going below 0 thing is working. Now this whole thing is still pretty simple, so let's go ahead and take it one step further. What if we have is wearing shield, and that's going to start as false. And now in the character test, maybe we want to implement the thing where if you're wearing shield, then damage is less. And so let's make a test for that. So we'll make a new test. I tend to copy stuff over a lot. You can kind of do whatever works for you. Take damage with shield. Okay, so let's initialize our character. We're going to start with HP is going to be back to 100. HP, what we're going to do is, take damage 10, but we want to make sure that the is wearing shield starts as true now. And so when you're wearing a shield and you take some damage, it should be less than if you weren't wearing a shield. And so we're going to say, copy this one over. And so in this case, we could check for the exact value, but another kind of more flexible way to do it is just, hey, we want to make sure that it's more than 90. Keeping it a little bit more loose like that, just making sure it's greater than 90 might give us more flexibility if we tweak the numbers of what the defense does in the future. So if we tweak it by 1, we don't have a failing test. We still know that the shield is doing something. It's kind of your call on how flexible you want the test to be. But so yeah, I'll update this to say assert true that character.hp is greater than 90. And now when I run this test, it's failing. And it's saying that HP should be greater than 90, but it wasn't. Okay, so let's make this one pass. We'll pop back open to character, and we'll say, yeah, if you are wearing a shield, if is wearing shield, let's go ahead and divide the amount that's coming in by 2. That way it should be less than if you weren't wearing a shield. Now run the test and see that everything is passing. So as you can see here, we've quickly spun up the beginnings of a battle or damage functionality system with a few features already, and verified that all the code is working as we expect without needing to fire up the game and test it manually. So this is really handy for working fast and working with confidence, knowing that everything is working properly and the game doesn't have bugs. And now we have these tests in existence too. So as we go on and add new features to the game, or maybe change things around, and one of these existing tests starts to fail, that means we have something to investigate because something changed somewhere, the outputs are different somehow, and so we may have introduced a bug to our game, and that's exactly what we don't want. And so having, this big list of tests can really help bulletproof your game and just becomes a really nice workflow as you go. And a quick word about Gut and GDScript in general is that it's super fast. I've been working on our new RPG project over the past few weeks and writing a lot of tests for that, hundreds of tests, and they all run in like milliseconds compared to some other language. I've done a lot of JavaScript in my past, and some of the test writing can be kind of a pain because some things run really slow, like they have to wait on processes and stuff. That's not the case here. Gut absolutely stays out of your way so that you can keep writing these tests and then keep having that security. So it's really worth checking out. Thank you so much for watching this video to the end. If you got something out of it, I really appreciate if you hit that like button. And if you're working on a game, you should join our Discord. We've got a really supportive group of people making games in all different kinds of languages. The link's in the description below. If you have a project you're working on, pop in there, tell us about it. We love to see you there. That's all for this one. Thanks, everybody. Happy testing. Catch you next time.